I'm assuming it didn't cut off that long ago. In case it did, they can always pause it. Okay. All right, so let's say, for example, we want to actually find the coordinates. Of the point on the unit circle at an angle of 180 degrees. Okay. Now with this one, again, if you draw a quick graph, you have 90 degrees, 180 degrees. Okay. If you have a unit circle and you go all the way to 180 degrees, and draw that quick unit circle, then at that point you're just at -1, 0. Okay, which is basically your answer. Okay, so that's the point on the unit circle. And theta equals 180 degrees. Okay. So sometimes they'll throw it in and make it look like it's a really long answer, but sometimes it's pretty short. Now, sometimes this very same answer will have a little bit of a longer step, but it's pretty similar to what we just did, where they'd want you to find the coordinates, or in some cases, the angle. Okay, so what if you want to find the angle between 0 degrees and 360 degrees, which intersects the unit circle at the point square root of 3/2, -1/2. Okay. So in other words, they want you to find x is positive, x is positive, y is negative. Square root of 3/2, -1/2. They want you to find the theta. So that means theta is going to somehow go all the way around and stop there. So that degree is going to equal some unknown, which is what we have to find. Okay. So the first thing you want to do is find the quadrant, which we just did. We knew that x is positive and y is negative. So we figure it's going to be in quadrant 4. Okay. So square root of 3/2, -1/2. X is positive, y is negative. So that means it has to be in quadrant 4. Now, if you had x negative and y negative, it would have been in quadrant 3. If you had x negative and y positive, it would have been in quadrant 2. Okay, now your second step is you want to find the positive coordinates for both of those. Okay, so instead of square root of 3 over 2 negative 1/2, you want to find out what value of theta will give you positive square root of 3 over 2 and positive 1/2. Okay, so square root of 3 over 2 and positive 1/2 goes through theta equals 30 degrees. Okay. Then after that, you want to find the reference angle. Okay, because we already know that if theta is 30 degrees, it would have been positive square root of 3 over 2 positive 1/2. So we want to find the reference angle that will now take it all the way there. We can't use the 2 pi minus there because it has to be positive. It has to be between, what is it, 0 and 360. So that's why we can't just use the 2 pi minus theta. No, oh, actually we can, duh. I'm thinking of a different problem. Sorry about that. Because that is, yep, that will still be 270. That will give us the right answer. Oop, find the reference angle. Okay, so in Q4, that would actually give us between there. So Q4 is equal to 360 degree minus theta. Oh, clean that up a little. Our reference angle in Q4. There we go. So it's 360 minus 30 degrees. So our reference angle is 330 degrees. So that means if you started here and you swung around 330 degrees, that's the point you end up at. Okay, so 330 degrees intersects square root of 3 over 2, negative 1/2. All right. Uh-oh. Okay, so definitions of trig functions. So right now, we've kind of just been messing around with sine and cosine. Okay, there are actually 4 additional trig functions we're going to work with, and they're all variations of sine and cosine. So if you know sine and cosine, you can kind of figure out the rest of them. Okay, so let's say if we have our, draw that because we're going to create kind of our graph, not graph, but our chart of all of the values. Okay, so this is our theta. Okay, so we have our cosine of theta. and we have our sine of theta. Okay, so right now we're just going to figure out those three. Okay, so we have our 0 power over 6, which is 30 degrees. Pi over 4, which is 45 degrees. Pi over 3, which is 60 degrees. And pi over 2, which is our 90 degrees. Okay. So remember, our cosine, that's our x, and our sine is our y. Okay. So remember, for your cosine, you're going to start with square root of 4 over 2, square root of 3 over 2, square root of 2 over 2, and square root of 1 over 2. Okay, which would give us 1, then square root of 3 over 2 and square root of 2 over 2 stays the same. That becomes 1/2, and that becomes 0. And we do the same thing for sine, but the other way. Square root of 4 over 2, square root of 3 over 2, square root of 2 over 2, square root of 1 over 2, square root of 0 over 2. Okay, which again gives us 0, 1/2, those two stay the same, and this becomes 1. Okay. So now, the other 4 is tangent of theta, which is equal to sine over cosine. Sine theta divided by cosine of theta. Oops, should have enough room to fit all of those. Okay, so if we have sine over cosine, you have 0 over 1, which is just 0. You have 1/2 over square root of 3 over 2, and I actually figured that out earlier. That would be, I might as well figure it out here. 1/2 divided by square root of 3 over 2 is times 2 over square root of 3, which is 1 over square root of 3. Or if you wanted to rationalize, it would be square root of 3 over 3. For power over 4, square root of 2 over 2 divided by square root of 2 over 2. Anything divided by itself is just going to be 1. Okay. This one, square root of 3 over 2 divided by 1/2. So square root of 3 over 2 divided by 1/2 would just be times 2. So that would be square root of 3. And 1 divided by 0 would be undefined. So that was our tangent of theta. So that leaves our cosecant of theta. So cosecant of theta, and that's just the reciprocal of sine. So whatever sine theta is, you just flip it. Okay. So if sine is 0, That means if you try to flip 0 over anything, it's just going to be undefined. Okay, so here if sine is 1/2, you end up with 2. Here, if sine is square root of 2 over 2, this would be 2 over square root of 2, which once you rationalize it by multiplying both by square root of 2, you end up with, put it underneath it since we're running out of room, 2 square root of 2 over 2. I'll put it next to it. 2 square root of 2 over 2, which is just square root of 2. Okay. So now if we get the reciprocal of square root of 3 over 2, 2 over square root of 3, and again, if you decide to rationalize the denominator, square root of 3 over square root of 3, that would be 2 square root of 3 over 3. And the reciprocal of 1 is just 1. Bring that down a little bit. Okay, so now we have secant of theta, which is just the reciprocal of cosine. So if you get cosine and flip it, you now have your secant. So that's secant of theta. Okay, so if you get your cosine, if you flip 1, you just have 1. If you flip square root of 3 over 2, you have 2 over square root of 3. Again, if you rationalize it by multiplying it by square root of 3 over square root of 3, you get 2 square root of 3 over 3. If you flip square root of 2 over 2, you get 2 over square root of 2. And just like here, you just end up with square root of 2. Once you rationalize it like you did there. Here, if you flip 1/2, you just get 2. And here, if you flip square root of 0 over 2, you get undefined. Okay, and we have one more. I'll put that on next sheet. And theta, make that equal 0. Pi over 6, which is 30 degrees. Pi over 4, which is 45 degrees. Pi over 3, which is 60 degrees. And pi over 2, which is 90 degrees. Nope, actually could have stopped right there since we only need one. So we'll continue here. Okay, and the last one is cotangent, which is just tangent flipped. So it's the reciprocal of tangent. Okay, so we have our tangent, and I'll see if I can slide that. Yeah, I got room to show it. So our tangent is 0. So if we flip 0 over anything, is any number over 0 is undefined. Okay, so we have 1 over square root of 3, which just becomes square root of 3 over 1, which is square root of 3. If we flip 1, it just becomes 1. If we have square root of 3, we end up with 1 over square root of 3. Which, if we rationalize the denominator, multiply by square root of 3 over square root of 3, which is square root of 3 over 3. And if we flip 1 over 0, we get 0 over 1, which is 0. So you can see they all just revolve around sine and cosine. So cotangent of theta. Okay, so if we were to write these out, you have sine of theta, cosine of theta, your tangent of theta, which is just sine of theta over cosine of theta. And of course, cosine can't equal 0. You have cosecant of theta, which is just sine of theta flipped. So whatever sine of theta is, you're just going to flip it. Of course, we know sine of theta can't equal 0. You have secant of theta, which is cosine of theta flipped, where of course we know cosine can't equal 0. And then you have cotangent, which is just tangent flipped. Or if you wanted to put it as sine and cosine, that's just cosine of theta over sine of theta. Oh, of course, here sine of theta can't equal 0. All right. Oh, I'll leave that up. I'll write on a new sheet. All right. It should be done in a couple of minutes. Okay, so let's say if we have, this is our first quadrant, our second quadrant, our third, and our fourth. Okay, so in the first quadrant, we know x is positive and y is positive, which means the reciprocal of sine is positive, the reciprocal of cosine is positive, sine over cosine is positive, cosine over sine is positive. They're all positive. Okay, so we know here, in quadrant 2, x is negative and y is positive. Okay, which means that cosine is negative and sine is positive. Okay, so if sine is positive, the reciprocal of sine is also positive. So that means in this quadrant, sine of theta and cosecant of theta are both positive. Oh, clean that up just a hair. Okay. Now in quadrant 3, sine is negative and cosine is negative. So x is negative, and y is negative, which means that cosine is negative, and sine is negative. The thing is, with tangent, you have sine over cosine. So you have a negative divided by a negative. So it's positive. So that means that tangent of theta is positive. And since cotangent is just tangent theta flipped, cotangent of theta are both positive. All right. And in quadrant 4, x is positive and y is negative, which brings us to cosine of theta is positive and sine of theta is negative. Okay. So since in quadrant 4, cosine is positive, the reciprocal of cosine would also be positive, which means secant is positive. Okay, so they're all positive in their own intervals except quadrant 1. Quadrant 1 is everything's positive there. Okay. Like I said, can't speak for everyone, but I had a horrible memory as a student, so I made up like a little, not really a rhyme, it's like a little, like kind of a rhyme, but it doesn't rhyme, but it's something to kind of help me remember this. And yes, it's going to make absolutely no sense, but you'll see where I'm going with it. Single cows can't. Tangle cots with cozy secrets. Uh-oh. I'm going to show you why that little saying got me through this class. Well, it helped get me through this class. Sine, cosecant. Okay. Remember, they're reciprocals of each other, and they're in quadrant 2. And positive in quadrant 2. Tangent, cotangent. Now they're reciprocals of each other and positive in quadrant 3. Then cosine and secant, they're reciprocals of each other and positive in quadrant 4. Like I said, that was just something to kind of help me get to understanding all of this. So hopefully you can find it useful. All right. Any questions on this one? All right. So I'll do one quick example, then I'll let you get out of here. And I'll actually add a couple that I have a few extra. I'll do